Right, let's jump straight into this. Welcome to today's explainer. Now, I want you to start treating your computer science exam like a high-stakes legal case. Seriously, you are the barrister, the examiner is the judge, and your code logic, well, that's your undeniable evidence. Mastering unconditional and conditional instructions is literally the absolute key to conquering the Cambridge 9618 examination. I mean, these instruction groups are the entire foundation of algorithmic thinking, whether you're using an unconditional JMP command or setting up an if, then, else structure. I can guarantee you for sure they are going to appear in every single examination series. But here's the real secret. Just knowing how to code? Not enough. No way. You have to know how to build a structured, airtight case that the examiners simply cannot argue with. So whether you're building up your foundational skills in syllabus codes 0417, 0478, 0983, 0984, or 2210, or you're staring down the barrel of the rigorous 9618 AS and A-level papers, this strategy is your absolute blueprint for success. Okay, so here's the exact masterclass agenda we're going to use today to build that top scoring case. We'll start with the challenge, move into the strategy reveal, then the transformation, hit up an interactive workshop, and wrap up with the final system. Let's get to work. Section 1. The challenge. Let's talk about exam hall pressure. Okay, picture this. You're sitting in the exam hall. The clock is ticking super loudly, you turn the page, and boom, you are hit with this massive, complex scenario requiring multi-step calculations using nested conditional instructions. The pressure in that room, it's intense. Your brain has to instantly parse all this raw data, figure out the algorithmic logic, and then write it out perfectly. This is exactly where so many incredibly smart students just completely freeze. They know the theory inside out, but they lack the strategy to execute it under pressure. Take Alex, for instance. Alex has literally memorized the whole textbook. But when asked about conditional loops, Alex just dumps a massive paragraph of generic raw facts about if statements and while loops. Zero analysis. It's just a wall of textbook definitions. And bam, the examiner's red pen strikes. 0 marks for application. On the flip side, we have Sam. Now, Sam is a super fast coder, but Sam rushes. Sam writes the algorithm, but completely ignores the boundary conditions and totally misses the specific command word in the prompt. The loop runs, sure, but it crashes hard on the edge cases. More red pen. This contrast right here is exactly why students lose marks. They either fail to analyze or they fail to check the boundaries. Now, what's really interesting is that this comes straight from the highest authority. This is a direct quote from the Cambridge Principal Examiner report itself. Read it with me. Answers are often too vague. The classic mistake is providing generic answers not specific to the question context. This is the ultimate examiner alert, guys. It proves without a shadow of a doubt that superficial breadth, just listing facts you've memorized, will never ever be logical, structured reasoning applied to the exact scenario given. Context is king here. If the question is about a temperature sensor in a greenhouse, your code and your explanation better be talking about temperatures and greenhouses, not just throwing around abstract variables like X and Y. Moving right along to Section 2, the strategy reveal. Let's look inside the mark scheme. Okay, so the assessment framework for instruction groups actually targets 3 distinct cognitive domains, and you absolutely must hit all 3. Column 1 is knowledge and understanding. This is just your baseline, like, can you actually recall the correct syntax for an unconditional JMP or conditional while loop? Column 2 is application. Can you take that syntax and actually use it in the specific context of the exam question? And column 3, this is the hardest one, is analysis. Can you evaluate the efficiency of your code? Can you explain exactly why a conditional repeat until loop is better for this specific data set than a fixed for loop? If you only ever hit column 1, you're severely capping your grade. So the absolutely crucial points here is understanding the method mark strategy. This is your ultimate safety net, and honestly, the smartest candidates abuse this to their full advantage. Examiners will actually award you points for your procedural framework and your logical process, even if your final algorithmic output has a bug in it. Let me just repeat that because it's huge. The systematic process of evidence-based reasoning is just as vital as the final answer. If you document your variables clearly, structure your conditional steps logically, and make your analytical framework visible, you're going to rack up those method marks, turning a potentially disastrous question into a really solid passing grade. And to absolutely guarantee you get those method marks, we use what's called the PEAL framework. That's point, evidence, explanation, link. It's a structured method to ensure every single written answer directly addresses the command word and the scenario context. You make your point about the instruction group, you provide your evidence from the code snippet, you give your explanation of how the condition actually works, and crucially, this is the big one, you link it back to the exam scenario. This is the ultimate tool to decode command words and avoid those vague, generalized technical details that examiners just hate. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at how we actually deploy this in action with a highly structured procedural framework for tackling literally any conditional instruction question. Step 1, deconstruct the question. Get your pen out and underline those command words. Step 2, extract the relevant data and constraints right from the scenario. Now, step 3 and 4 are where most students completely stumble. Step 3, select the analytical framework. Like which type of loop or condition is actually required here. You have to choose the right tool for the job. Step 4, execute with clear notation. Please don't get sloppy here just because you think you know the answer. And finally, step 5, present with correct terminology. If you walk through these 5 steps, you're building an airtight case. You are basically forcing the examiner to give you the marks. All right, section 3, the transformation. Let's put this theory into practice. Let's look at a before answer. Remember Alex? Alex wrote, use a loop to check the data. I mean, it's factually true, but it's terribly vague. It's gonna get 0 marks. Now look at the rewrite using our framework. Implement a conditional while loop to continuously verify the sensor data until the boundary condition is met. Do you see the difference there? We didn't just casually say loop, we specifically set a conditional while loop. We linked it to the specific context, the sensor data, and we justified its execution by explicitly mentioning the boundary condition. This links the code implementation directly to the specific scenario, and it adds immediate, undeniable marks to your score. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, section 4, the interactive workshop. Time to test your skills under pressure. Welcome to Challenge 1, Data Scan. Imagine a complex conditional loop structure right in front of you. You have exactly 60 seconds. In the real exam, you cannot read every single line leisurely. You have to visually extract the core trend immediately. Is it an unconditional loop that just runs indefinitely? Is there a nested if statement that creates a conditional break? You have to scan the indents, find those command words, and extract the logic flow before that timer hits 0. Time management right here is absolutely crucial. Next up is Challenge 2, find the flaw. Take a look at this flawed statement. The algorithm sorts the array efficiently, but fails to account for empty inputs. So why does this lose marks? I want you to think about what's missing here. Well, the answer is that it completely lacks context-specific justification. It mentions a failure regarding empty inputs, which sure is an edge case, but it doesn't explain how that edge case affects the specific system in the exam scenario. It doesn't link the flaw back to the user or the hardware context. You must always explain the actual consequence of the boundary condition failure. And now, Challenge 3, speed writing. You've got 30 seconds on the clock. In an actual exam, you might only have a few minutes to evaluate an algorithm's trade-offs. I'm pushing you to draft one perfect Peel paragraph. Point, evidence, explanation, link. If you can quickly articulate why a specific unconditional instruction, like a JMP, creates a faster execution time than a complex nested conditional structure, and then link it back to the scenario's need for speed, you win. 30 seconds is literally all it takes to secure top marks if your framework is fully memorized. Finally, Section 5, the final system. Let's lock down your exam blueprint. This right here is your evaluative thinking checklist for the final stage of the deconstruct, solve, evaluate methodology. Whenever a question asks you to evaluate an algorithm using conditional or unconditional instructions, you run straight through this list. Have you discussed time complexity? Does the condition make the code run slower? What about space complexity? Does it require extra memory? Did you thoroughly test for edge cases, like what happens at 0, at maximum capacity, or with totally invalid data? And finally, did you provide justified recommendations? You can't just point out flaws. You must suggest actual improvements based on your evidence. Let's recap the complete computer science success blueprint. These are the 3 golden rules that guarantee maximum method marks. Rule 1, command word decoding. Never, ever answer evaluate when they ask you to describe. Rule 2, Peel framework application. Structure every single written answer logically so the examiner literally cannot ignore your points.
Rule 3. Time Management Matrix. Allocate your time based exactly on the marks available, ensuring you leave plenty of time to check those vital boundary conditions.
And why do we go through all this trouble to structure our answers like a legal brief? Because of the raw data. Students who actually implement these computer science strategies, specifically this evaluative thinking system, see an average improvement of 2 whole grade boundaries. That is literally the difference between a C and an A. But listen, that transformation only happens if you practice this analytical framework consistently.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I want to leave you with a final thought about your own coding practice. Think back to the last past paper you attempted. Honestly, did you rigorously check your edge cases and boundary conditions, or did you just write a generic answer hoping for the best? It's time to step up. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. AC Exams, your Cambridge success starts here.